Hello friends, so let's continue with the chapter solutions. We have covered the first part, which is expressions of concentration. In this part we are going to cover a very important topic called solubility. This is a very simple concept, but it is very important as well. So we'll give a read through and we will try to understand the concept on the go. Okay, fine. So it goes like this: every solid does not dissolve in a given liquid. Okay, while sodium chloride and sugar dissolve readily in water, naphthalene and anthracene do not. On the other hand, naphthalene and anthrene dissolve readily in benzene, but sodium chloride and sugar do not. It is observed that polar solutes dissolve in polar solvents. Please underline this. This is keyword. Polar solutes dissolve in polar solvents and non-polar solutes in non-polar solvents. This is a key point. Polar solutes means solutes with charge, in the sense NaCl, Na is having a positive charge, Cl is having a negative charge. This is a polar solute which will dissolve in water, which is H2O, wherein H is having a negative charge and this is having a positive charge. This combination is what is being explained here. To put it in simple terms, it says like dissolves like. Fine. This is the main concept behind solubility. Next we'll proceed. When a solid solute is added to a solvent, some solute dissolves and its concentration increases. So solute dissolves and concentration increases. This process is known as dissolution. We have already seen that the word dissolve and solution is synonymous. We'll continue. Some solute particles in solution collide with solid solute particles and get separated out of the solution. This process is known as crystallization. So there is the first process, which is dissolution, second is crystallization, and a stage is reached when two processes occur at the same rate. Under such conditions, the number of solute particles going into the solution will be equal to the solute particles separating out. This is known as dynamic equilibrium. So step 1 is dissolution, and then if enough amount of dissolution happens, step 2 is crystallization, and when 1 is equanimous with 2, this state is called as dynamic equilibrium. This is the crux of what is being said here. Okay, so it says at this stage the concentration of the solute in solution will remain constant. Concentration will remain constant, that is temperature and pressure. Similar process is followed when gases are dissolved in liquid solvents. Such a solution in which no more solute can be dissolved is known as saturated solution. Fine. So saturated solution means no more solute is dissolved. This is keyword. Fine. So we'll proceed. So unsaturated means some more solute can be added. Solute can be dissolved. The solution which is in dynamic equilibrium with undissolved solute is the saturated solution and contains the maximum amount of solute. So the maximum amount of solute is contained in a solution which is in dynamic equilibrium. That is what is being said here. So in short, solubility is 3 steps: dissolution, followed by crystallization, and then these two, when are in equilibrium, this is called dynamic equilibrium, and such state it's called a saturated state. This is the essence. Now we will see the effect of temperature on solubility. Solubility of a solid is significantly affected by temperature. How? Something called as Le-Chatelier's principle, which will come later. In general, solubility should increase with a rise in temperature for an endothermic solution, and if it is exothermic, where delta H is less than 0, the solubility should decrease with increase in temperature. So if the delta H of solution is greater than 0, that means if it is going to absorb heat, that means the solubility is going to increase, obviously, because if we raise the temperature, it is going to raise the solubility. But reverse case, if it is going to raise the temperature, additionally the solution itself is exothermic, so it is going to give away heat, therefore the solubility is going to decrease. Effect of pressure. Pressure does not have significant effect on solubility of solids. However, pressure will have an effect when gaseous solutions come into picture, which we will see in the next section. So hereby we have revised the concept of solubility. Fine. Okay, that's about it. Thank you so much.